Hi, hello. Welcome to the first day of Unit 6. So this unit is a math unit. So we are going to be doing dimensional analysis again. So throwback to one of our very first units. And so we're going to refresh on that. We're going to talk about refresh on molar mass that we did as well before we move into how to calculate and convert from grams of a substance to moles of a substance. So, but to start, let's do a little refresh. So we've got a warm-up. There's these 3 questions. It says, what is the formula for titanium 3 carbonate? What is the molar mass of titanium 3 carbonate? And then set up the dimensional analysis to convert 3,487 milliliters to liters. So for this first one, you should be able to do that yourself. You just took your test over it, so this should be something that you can do. Okay, so for titanium 3 carbonate, write that formula, pause it, and then come back. Alright, so the formula for titanium 3 carbonate should be Ti2 CO3 3. Alright, so then next it asks, what is the molar mass? So as a reminder, molar mass is taking the mass of each element and then multiplying that by how many of that element there are in your compound and adding them all together. So we have 3 different elements in titanium 3 carbonate. So we need to use all 3 of those. So I'm going to separate it into the elements. So titanium, carbon, and then oxygen. So we're going to look at our periodic table and find titanium. So titanium is over here. And the molar mass of titanium is 47.90. So we're going to write 47.90. And then how many titaniums are there? Well, there's 2 titaniums in titanium 3 carbonate. So we're going to multiply this 4790 by 2. Next we'll do carbon. Carbon, we're going to look at our periodic table again. Carbon, the mass of carbon is 12.01. So we're going to do 12.01, and then how many carbons are there? So there's 1 carbon in 1 singular carbonate, but we have 3 carbonates, so we're going to do 3 times 1. So we have a total of 3 carbons. Last is oxygen. Oxygen has a mass of 16, so we're going to do 16 times, and then we're going to do 3 times 3, so we have a total of 9 oxygens. So we're going to plug these numbers into the calculator. So we're going to do 47.90 times 2, and whenever we do that, we're going to have 0.90 times 2. We're going to get 95.80. I'm going to do that for carbon, so carbon is 12.01. times 3 gives us 36.03. And then oxygen, we have 1600 times 9, and that gives us 144. And then we're just going to take all of those numbers and add them together. So whenever we add them, we get 144 plus 95.80 plus 36.03. So our molar mass for titanium 3 carbonate is 275.83 grams per mole. And that unit is really important. So do not forget that molar mass, the unit is grams per mole. You have to remember that, and that's going to be super important in what we do this unit. Alright, the last question is set up the dimensional analysis to convert from 3,487 milliliters to liters. So remember, dimensional analysis is those things with the parentheses and the lines that gets us from one unit to another. So we always start by writing our given, and our given is that number that's in the problem. So that number is 3,487 milliliters. And we need to get to liters. So the conversion to go from milliliters to liters, 1 liter equals 1,000 milliliters. And remember, our whole goal is to cancel our units. So whatever unit we start with, that unit goes on the bottom. So I'm automatically going to put this ml on the bottom. Not the starting number, just the unit. Then I'm going to look at my conversion here and say, okay, I've got ml on the bottom. What's the number that goes with ml? What's stuck with it? That's the 1,000. So I'm going to do 1,000 milliliters on the bottom. And then the other side of my conversion, this equals 1 liter. So 1 liter is going to go on top. And whenever we do this, this cancels out the milliliters, leaving our unit in liters. And so we're going to plug this into the calculator. So we're going to get 3,487 times 1 divided by 1,000, close parentheses. And that gives us 3.487 liters. And that's our answer. So this unit, we are going to be using dimensional analysis, what we're doing here, but we're going to be going a little more in depth, and we're going to be using molar mass and then something called Avogadro's number. Now, you should have picked up from the front not only this notes packet, but also this little sheet of paper. So this is yours to keep. Okay, this is what we call the mole heart. This is going to be your friend for this whole unit. You get to use this on your assessment. This is your own personal copy that you get to use while doing your notes and your practice worksheets. Whenever you take your assessment, you will get a nice big class copy one that you can't write on. But this one you should have picked up from the front, and this is yours to keep. So, the whole point of this mole heart is that moles, which is our unit that talks about an amount of chemicals, right? Our mole is our heart. That's our center. Everything has to go through the heart. So if you think back to biology, the heart is where all of the blood gets pumped out of in order to go to different parts of the body. In order to get from one unit to a different unit, we have to go through moles, just like how our blood has to go through our heart to get pumped out to wherever it's supposed to go. So we have to get to moles. If you are not using moles in your problem, you are doing it wrong. Moles are going to be used in every single problem where you're doing dimensional analysis. All right? So what we can do, and today all we're going to use is this, but I'm going to talk you through the whole thing. So moles is how we get from one thing to another. So we need to make sure that we get to moles, or if we're already in moles, we know how to get out of it to whatever we want. So today we're talking all about grams to moles or moles to grams. So we're going to be using this half, okay? And we can use molar mass to convert from grams to moles or moles to grams. So that's why I said molar mass up here is really important, and we're going to be using it because that is our conversion. That's how we get from moles to grams or grams to moles. And this here tells you. So based on what your problem gives you, for example, this first problem here says how many moles are there in 100 grams of aluminum sulfide. So we're given 100 grams, so we know we're starting here, and I need to get to moles, so this tells me I'm going to use molar mass as my conversion to get from here to here. Now, you still have to be able to know how to calculate your molar mass, but this is going to prompt you a reminder that says this is what you use to go from here to here or here to here. Now, next class, we're going to be adding on a step, and we're going to be talking about particles. So particles is just kind of like this big umbrella term, and it can mean atoms, formula units, molecules. If you see any of these words here, then you're going to particles, and you're going to be using this number here. This is Avogadro's number. This is on your formula chart, as well as here on this mole heart that you get to use. So instead of using molar mass to go from grams to moles, you can use Avogadro's number to go from particles to moles or moles to particles. And if you have to go from grams to particles, well, that would tell you, okay, I have to get to moles first. I can't go straight from grams to particles. I have to get to moles using molar mass, and then I can use Avogadro's number to go from moles to particles. So this here is a really handy tool that helps remind you what you need to use as your conversion to go from one thing to another. So we're going to be using this today, but today, like I said, we're only going to be using this half of it. So looking at this first example here, it says how many moles are there in 100 grams of aluminum sulfide? So the first thing you have to be able to do is write the formula. Now, on this set of notes, we're going to be writing the formula, but on your assessments, you will be given a list of formulas, and you'll just have to choose the correct one. So you won't have to write it from scratch. That's what we're doing on our notes. But on your assessment, you will be given a list, and you will look for aluminum, whatever the formula for aluminum sulfide is from the list, and choose the correct one. It'll still be worth 1 point, but instead of having to write it from scratch, you'll just have to choose the correct one from the list. So we're going to start. So the formula of aluminum sulfide, so aluminum has a charge of +3. Sulfite, if we look at our it ends in ITE, so that tells us to look at our polyion list. Sulfite is here. That's SO3 with a charge of -2. So we can do our crisscross, and whenever we do that, we'll have Al2 parentheses SO3 3. And then we have to find the molar mass. So we're going to break it up into its elements, Al, S, and O. So we're going to look at our periodic table. Aluminum, the mass is 26.98. And there are 2 aluminum, so we'd multiply by 2. Sulfur, the mass of sulfur is 32.06. And there are 3 of them, because 3 times 1 is 3. And then oxygen, the mass of oxygen is 16. So we'll do 16 times 3 times 3 is 9, so times 9. And we'll plug that into the calculator. So 26.98 times 2 gives me 53.96. 32.06 times 3 is 96.18. And then 16 times 9 is 144. And we're going to add all those numbers up, and we're just going to 2 numbers after the decimal here. So we'll do 144 plus 96.18 plus 53.96. And that tells us our molar mass is 294.14 grams per mole. And that unit is really important because that's going to help us figure out where our number needs to go. So now we can actually start the dimensional analysis. So it's asking us to find moles whenever given grams. So this is our given. Always, 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 we're going to write that first. So we'll do 100.0 grams, and then we're going to write the formula. So we'll do Al2 SO3 3. It's 100 grams of aluminum sulfide. Okay, now I know that's dimensional analysis, so I can go ahead and set up my conversion here. My unit, the unit that I start with is grams, so grams goes on bottom. And then I can see, okay, I need molar mass. I need to use molar mass to go from grams to moles. Well, the unit for molar mass is grams per mole. So this can be written as 294.14 grams per 1 mole. It can be rewritten as that. This is what that means. So if grams goes on the bottom, the other unit that goes on top is going to be moles. And then we're going to pick the number that goes with each one. So gram, the number that goes with it is the 294.14. And then the number that goes with moles is 1. Then we're going to write our aluminum sulfide again. And so by doing this, we've canceled out grams, and we're left with moles. We used our molar mass that we calculated here and plugged that into our dimensional analysis as a conversion. So then we just plug this into the calculator. So we're going to do 100.0 times, parentheses, 1 divided by 294.14, close parentheses. And that's going to tell me a long number. I'm just going to write out to here, okay, and my unit is moles. And then here, so we're back to sig figs. So this here has 4 sig figs, 1, 2, 3, 4. So as a reminder, if there is a decimal, we count from left to right. If there is no decimal, if it's absent, we go from right to left, starting with our first non-zero and then counting until the end. So our first non-zero is here because we're going this direction. 1, 2, 3, 4. So I need to have 1, 2, 3, 4. But then I need to round, so I'm going to look at that 7, and that 7 tells me I'm going to round up. But that 9 is going to become a 10. That 9 is going to become a 10. So what's going to happen is this is going to be 0.3400 moles of aluminum sulfite. Now, we are going to be a little forgiving on your sig figs, okay? Really, as long as you don't give me a ridiculously long number, you're going to be okay. So I still want you to round, and I definitely do not want you to give me, there's a whole number here from the calculator, okay? But what I wrote down here was 1, 2, 3, 4, 5 sig figs. If you give me this, you're going to be okay. Alright, so the next problem says how many grams of zinc oxide is in 1.34 moles of zinc oxide. So we're using zinc oxide. So zinc has a charge of +2. Oxide has a charge of -2. If we did the crisscross, we'd realize that it would be Zn2O2, but we can simplify and do ZnO. If we did the math, we'd realize we only need one of each to get it to be 0. So we would have ZnO. And then on your assessment, you would just look for ZnO on the list, and that would be the correct one to choose. Alright, so now we're going to do the molar mass. So we're going to break it up into the element Zn and O. And I do want to point out that this, whatever you see here, this is exactly what your assessment is going to look like. You're going to be given this box, this table, and you're going to fill it out, and it's going to be exactly like this. So Zn, the formula, the mass for Zn for zinc is 65.39. And there's one of them. Oxygen is 16. And there's 1. So we've got 65.39 and 16. We're going to add them together. So whenever we do that, we'll get 65.39 plus 16. And that gives me 81.39 grams per mole. Alright, so now I'm doing dimensional analysis, and like I've said before, dimensional analysis always starts with your given, what's been given to you in the problem. That's 1.34 moles, so that's what we're going to write down first. 1.34 moles zinc oxide. Okay, and then it's asking me to solve for grams. So I'm going to look at my mole chart and say, okay, I'm here at moles. I need to get to grams, which is over here, so I'm going to use molar mass. I'm going to use this here. So I know that whatever unit I start with, that's the unit that goes on the bottom. And so the other side is going to be grams. So this 81.39 grams is what goes on top. And then our 1 mole goes on the bottom. Because remember, we're trying to get out of moles, and the only way we can get out of moles is by putting it on the bottom. And then to double check, whatever unit we're trying to get to should always end up on top. So we're solving for grams. Grams is on top. So we set this up correctly. So now all you have to do is plug it into your calculator. So we'll do 1.34 times, parentheses, 81.39 divided by 1, close parentheses, and that gives me 109.0626 grams. Now, this gives me 3 sig figs, so I'm just going to report 109 grams. So that's it. Those are the two types of problems that you're going to be doing. But if you flip to the next page, there is practice. So I want you to go do this one here and then come back. So pause the video, do this first problem, and then come back and check. All right, so here is the answer. You should have gotten 0.313 moles. So whenever you did your formula, tetracarbon tells you 4 carbons, dibromide tells you 2 bromines. So we're going to break that up. We're going to do 12.01 times 4, 79.90 times 2, and our total molar mass is 207.84 grams per mole. Okay? So then we're going to start with our given always, that's 65 grams. We're going to do 65.0 grams of tetracarbon dibromide. And since we're starting with grams, that tells me grams goes on the bottom. And so I'm going to use that 207.84 grams on the bottom, 1 mole on top. Whenever I plug it into the calculator, I'll get 0.3127. This has 3 sig figs, so I'll say 0.313 moles. But if you give me 0.3127 moles, you'll be fine. All right, so do this last problem, and this one I'm going to go ahead and give you the formula. So the formula for barium carbonate is BaCO3. So go ahead and do this one, and then come back and check your answer. All right, and your answer should be 14,800 grams, or if you chose to use scientific notation, 1.48 times 10 to the 4th grams. So we calculated our molar mass, and we should have gotten 197.34 because there's 1 barium, 1 carbon, and 3 oxygens. And then we'll notice that 7.50 moles is our given, so we always start off by writing that. And then it's asking us to get to grams, so we'll use molar mass. Since we start with moles, moles has to go on the bottom to cancel it out, leaving grams on top, that 197.34. We'll plug that into the calculator, and this is the number we'll get. So if you have any questions, please come see any of us in tutorials. Next class we will expand on this and talk about how to get to particles. So I hope y'all have a great rest of the day. Again, come see us if you need us. Otherwise, bye.